Welcome back to my channel. My name's Brian Kafferke, and I'm a data and AI enabler. And this is an exciting topic we're going to be talking about, which is maintaining data in SQLite with Python, part 1. And this is actually talking about what I'll call the more traditional methods of insert, update, and delete. So please like, share, and subscribe, and let's jump in. And by the way, as usual, I'm branded with my Python shirt, drinking out of my Python mug, and wearing my Mars project hat that I got from Microsoft, so I'm all set to do my riveting presentation. If you don't know, I put this in all my videos now, but I wrote a book, really excited about it. Took me almost a year to write. I left Microsoft just to write this book. It's a book about Apache Spark, but it's written about Azure Databricks, which Databricks is a company founded by the creators of Apache Spark, which is a wrapper around Spark to make it easy to use and give you extra features. And Databricks on Azure is a really cool thing because it's all cloud-based and gives you a lot of extra features. So whether you want to know about Databricks, Azure Databricks, or Apache Spark, it's actually a really good book. It's very comprehensive. I wrote it because there's nothing like this out there yet, and I wanted to have something that would help people learn how to use the product thoroughly. So it's a comprehensive resource, and it takes you using a use case, step by step, from what the problem is in the company all the way through to the end of building out the ETL and the extract, transform, data munging, and even getting into data science solutions using Databricks machine learning tools as well as Azure's machine learning service to kind of see how you can build and deploy machine learning models. So it really takes you all the way from exploratory data analysis to the end game. It's available on Amazon, and I will point out that it's a very long book. I have had people hit me up and say, hey, is this available in a PDF or printed edition? I may go to printed edition, but it's a little like War and Peace. It's a thick book. I did not go light. I wanted people to really get a lot from it. It's well organized, so you can take what you want. For instance, PySpark, the Python integration with Spark, is thoroughly covered, but it's isolated from SparklyR and SparkR, which are R-based, as well as Scala and all these other things. So really, the ebook is the better way to go, and my recommendation is you would follow it using the step-by-step use case and the notebooks and code and data that goes with it, so you can really follow along. So take a look. Now, you can get a Kindle reader on any device. So whether you want to read it from your iPhone or any phone you got or any laptop or tablet, there's a reader out there for free you can get from Kindle, and you can read it. So don't let that stop you. Have fun. Where are we going in this discussion? I want to talk about what is data maintenance. Why do I even care? Why do I want to maintain the data? The traditional data maintenance language statements, DML, which are a subset of statements of SQL. And I'm going to talk about tools of the trade. Something will help us do this more effectively called SQLite Studio. And I have a whole video on that as well. And then, of course, my riveting demo. So the problem is table maintenance. Now, in another video, I go into great depth. I'm a big proponent of using SQLite, which is a built-in database with Python. If you use Python, you already have SQLite. You don't have to install packages. You don't have to do anything. It's already there, which is a great idea. It's really useful to have a database in any language, but usually you have to do things to get it, install it, and then if you give something to somebody else, they can't use it. The nice thing about SQLite is anybody with Python has it. And since SQLite stores its database in just a regular file, you can just put it on a floppy even and hand it to somebody or email it or whatever you want. The database is just a file, but all the data is stored in there in table formats, etc. And the SQLite interface can get at it. So this is really a win-win. And in my other video, I do a whole thing about how I recommend, bring data down from SQL Server or Oracle, whatever it is, and persist it into a local database where you can munge and data wrangle and do your analysis to your delight. And I would probably even clean it up and maybe create a little bit of a data warehouse. So that's been my sort of shtick that I push in other videos. But there is a problem when you do this. And by the way, if you do that, don't put personally identifying any kind of secure, sensitive data into a SQLite database. I don't recommend that because it's easy to pass around. Anyone can open it. There's no security. SQLite is a very different database. Take a look at my other things. It is a robust database, but it takes a bit of a mind shift, because this is not a typical database like SQL Server or Postgres that sits on a backend server and you send statements over to. SQLite is designed to be local to the language you're using. Side note, it doesn't even support stored procedures, and the reason is, and I read this from the SQLite documentation, they're like, well, Python's your stored procedure language because you're local and you can write functions or objects and classes and integrate that very easily with the database. And I think they're right. So there's some nuances here. So let me talk about this a little more. So assume you've taken my advice and you're now persisting data in your local database. Well, guess what happens? Data changes. Say we're going to use an example, for instance, a customer table. Well, new customers get added. People have changes. Maybe they get married and their name changes. Whichever one changes their name. Maybe they have other changes that go on. Like, for instance, maybe we have a salary information or other things we'll see, and that changes. They may no longer be customers. Maybe they left the country or whatever, and they're no longer a customer. Whatever it is, the data we want to maintain, there's add, changes, and deletes. And if you ever heard the term CRUD, create, replace, update, and delete, I think that's what it stands for. Not sure what the R is, but anyway, that's kind of the idea of you make all these changes to data. So you're going to get these changes, right? We need to get those into our database. How do we do that? Typically, we want to have like a local table that we put in the database and bring those changes, those transactions we call them, into a table in the database where they're easily applied to our table in SQLite. Now, where these changes come from, there's a lot of ways it could happen. For instance, it could be that we get a file from outside. Maybe we maintain vendor information from invoices. We have invoice lists, for instance, and the vendor sends us information like that, which we load into our database. So we can get new updates to that. They may even identify on their own, like this change, and we know from what they give us what's a change, what to delete, what's an add. It's also very possible we have something like an enterprise database, as shown here, where we're really getting the data from that. It might be SQL Server or Postgres, MySQL, etc. So we pull the data down into our database, but it's going to keep changing, right? So we need to get those updates. Now, a couple of ways to do that. One way is to just bring the whole table down and just delete and replace it. But if it's a large database, or maybe we're taking data, sources from one database here, another database here, so we've got customers coming from our Salesforce over here, but they also use Dynamics over here, so we're going to merge the data from there and these two sources. And then we have other, customers that are in some sort of other system. And while that's not in one place in our sources, we've got it in one place. So that's another good reason we can't just truncate, which means delete all the rows and load it again. We have to do some sort of update. But if we could, we might do that. We might also do some process where we compare the source data to our database and then figure out what is an add, change, update. But we're going to see how do we apply these kinds of changes. That's the goal here. But the point of this slide is simply to say data changes and we need to get those changes. So why do we care? Well, we talked about the data is constantly changing. And we may not be able to just drop the table and replace it every time we want to. I work with databases which have hundreds of millions of rows, sometimes billions of rows, and that's not something you're going to want to drop and replace, especially with something like SQLite. You want to make sure you have data that is current and reliable, right? Because you're building analytics solutions. You're going to be doing, cool visuals, or maybe training machine learning models. Well, if you're using outdated data, you're going to get something called model drift, which means that model's not predicting according to the real world anymore. So you want to make sure you've always keeping this data up to date. Now, I've worked for years and years in extract, transform, load, ETL work, and that's all it's about, pulling the data from somewhere, merging, munging, etc., and putting it out again in a clean format that's reliable. So traditional DML statements, we have several. So when we want to add new customers, for instance, to a customer table, that's called an insert. So we've got the insert, like that cool insert button, right? You want to update, apply changes, maybe a name change or something, we use the update. And we want to get rid of rows, something no longer a customer, something needs to be removed, we use the delete statement. So we've got, those are the three really maintenance DML SQL statements. So we're going to take a closer look at that. Now I'm going to show you something later which kind of helps make this easier, called an upsert. But I want to give you the background first in using the traditional statements for a couple of reasons. One, it's loaded with nuances and you can find yourself get stuck. So I do encourage you to stay with me through this video because you're going to learn a lot of things that are not easy to find. I did a lot of research to figure out how to get around certain problems. The DML statements, especially the update in SQLite, is really weak. I don't know why it's such a bad SQL update statement, so I'm going to show you a way to get around that problem. There's a number of ways that are talked about updating data. the traditional way, and then I'm going to show you Upsert. And there is one other way, which I'm going to use a little bit of in this video to kind of get around the update limitations. So stick with me as we go through this a little more. Now, one of the things I want to talk also about is when I do work, I find that whenever I'm working with a database and I'm doing something with Python or R or something and I need to work with the database, it's really valuable to have a visual interface to the database system. It lets me query, look around, and it's nice to have because then I can sort of double check what I'm doing. I can also test out the syntax of what I'm writing. So I'm trying to do, for instance, update, insert, etc. It's nice to have a place I can just run it as a sort of test in the SQL editor and then bring it into Python. Because Python's not SQL. It's not meant to be just this direct interface to a database. So this is a great tool. It's called SQLite Studio. Click on the link. And you just download it. It's free. It's great. It shows you all these documentation and stuff. And by the way, I'm going to put a link in the description which shows you where you can get the slides and the content and the code that goes with this video. So check that out. I'm using a Jupyter Notebook to walk through the code. You can extract Jupyter Notebooks to regular scripts and things. It's built into the interface. But anyway, so you want to use this thing called SQLite Studio. Go in there, download it, and check out my video. I'll put it in the links as I mentioned, and then you can go there and watch that riveting video. Now, if I go over to my implementation, I have SQLite Studio installed. I'll show you this. Now, for the Upsert, you need to make sure you have a pretty recent version within the last couple of years of SQLite Studio, because SQLite Studio also comes with the SQLite database functionality. And if it's out of date, it won't understand later features like the Upsert. We're fine now. It's very unlikely to have any problems with this particular code because this goes back a ways. So we can see in this database, I opened it up already. So if I want to open up a new database, I can just say add a database, find it, and add it in. Now in SQLite, a database is just a file, right? File name with a .db extension, all right? So we have this AW, which we're going to use. And I'm going to drop these tables and recreate them as part of our testing here. But you can see I get a lot of information. For instance, I already had this running, but when you double click on a table like this, it brings up a description of it. And notice you have tabs, so I can even look at the data. Now, you may not want to do that if there's a lot of data, but I can see if there's constraints on the table. I can see triggers, and I can even get the create table statement, which is handy. If I wanted to create a table similar, I could just cut and paste this, make a few changes, and I can create a new table. And there's all kinds of features. Notice I can right mouse click. I've got all kinds of functionality. I can import tables, all this stuff. So again, having this, I really like having SQLite Studio with me because it's just a really nice way to interact and kind of cross-check things while I'm working in Python. And I work with something called SQL Server Management Studio with SQL Server all the time. And honestly, I'd be lost without it. This, again, this notebook is available. It's on GitHub. It's called Python SQL DML. And you can see here, it says for demo purposes, that's my sort of non-disclosure and disclaimer to say, use this at your own risk. It's not intended for production use. You're going to make sure you're meeting standards and et cetera, for your company. But it's really meant to just show you how this works so you can apply it on your own. Documentation for SQLite is available here, so you can follow that link. And let's jump in here. What we're going to do is we're going to import the SQLite 3 library, which you already have if you have Python. And then we're going to display the version, and I'm going to bring in pandas because I use pandas a lot with SQLite. It has some really nice functions that allow us to sort of use SQLite directly without any extra work. I have this thing here to remind myself to warn you. Back in a long time ago, they had a show called Lost in Space, and in Lost in Space there was a robot that always like, danger, danger, Will Robinson. The danger here is, and I hit this myself, you must have version 3.240 to use the Upsert statements. Now we're not going to use that here, but if you do go to my next video, we will. So I had this as sort of a warning to remember. Upsert is a sort of way to integrate your insert and update into a single statement. So we'll see that later, but even with older versions, I think for the code you're going to see in this video, you're okay. So now that we've imported the SQLite libraries above and we're good, I'm going to create a connection to the SQLite database. And here, it's just going to be connecting to a database, which you've already seen it exists for me, which is called aw.db. Now, bear in mind that if this file doesn't exist, it will just create it. And there's nothing special really about the file. It's just a file, a flat file with a DB extension, stands for database. That's how SQLite works, and that's what makes it really kind of nice, but it's unusual for, you know, a commercial type of or enterprise level database to do that. That's why SQLite is really not intended for that. It's intended to be your local client type of database. All right, so we're going to run this statement here. And what that did is it returned a connection object. And that connection object, CONN is what we called it, is going to be used anytime we want to do something with this database. All right, so I'm going to say this again, and I'm going to show you why I say this, but I've used a lot of different databases over the years, including, you know, DB2, Oracle, SQL Server, and Postgres, and I generally find that the DML statements are pretty good. Typically, they're built so that you can join to your target data, your input data, and easily then use it to update, delete, etc. against your target. So typically you have a source, which is your transactions, and you want to update the target, your master table, they call it. But SQLite's transactions are pretty weak. I'm going to show you that, and I'm going to show you ways to get around it, so stick around. Now I'm going to be using data, particularly here called, okay, this dim dimension, you can see it over here. So there's this demonstration that's taken from Microsoft's AdventureWorks database. It's a fictitious company that Microsoft uses to demonstrate SQL Server, and they typically have new updates each year that goes along with the versions of SQL Server. So this version comes from the version for 2017, and this kind of gives you a quick overview of what the data is. Now I'm not going to show you updating all of it. I'm just going to show you the dim customer, and I'm not even going to bother calling it dim customer, which stands for dimensions. I'm going to bring in the data and just call it customer. I extracted the data from the database to CSV files so we could kind of walk through this and recreate and delete as we need to see how this works. So we need to create a table with a primary key before we save data to it. Now in my other videos, I tend to be very big on create a data frame from like a CSV file or wherever you get it, and you can very easily just save it directly into SQLite as a table. But when you do that, you don't get a primary key, and there's no way to really create one when you do that. So we need to create the table definition before we save the data. You may say, what's a primary key, Brian? I don't know what you're talking about. A primary key is something that is the unique identifier for an instance of some entity, which means, in this case, a row in the database or a table. So we have a customer. We've all seen things, customer identifiers. A person's identifier in the US for like tax purposes is a social security number. A social security number is unique to a person. So if you had a list of people, there would have to be a separate row for every individual person and their social security number. And in the similar way for customers, we need a unique customer identifier. Now things like names are not unique, so we need usually a number. And companies, any system, including AdventureWorks, has a unique identifier called customer key. So let's take a look at using customer key. Now the reason we need this is because when we say update, say the name or some other information about a customer, we have to be very specific. It has to be for a single person. And so we need to make sure we do this. If we want to say delete, even more important, right? We're going to delete the row. We want to make sure we get the right customer. Now I'm going to explain a little bit too about ETL processing and best practices because I've done this for a long time. And while I'm demonstrating this to you, I'm also going to show you some value-added things you can pick up and learn to make your work go better in your professional life. And one of the things that you want to do is you want to make your code rerunnable. What does that mean? It means that I should be able to take any program I wrote or notebook and just say run it from top to bottom, and it runs no breaking, no problem. Now if I were to say in this statement here, drop table customer, it would work as long as the customer table didn't exist. But if it didn't, it would fail because it would say I tried to find it, it wouldn't, and that could stop my notebook from running and other pieces of the notebook fail, and so it becomes a problem. So one of the ways to make your code more resilient is to do it more like this, include the if exists. So if the customer table exists, then it will drop it. If it doesn't, no problem, it just continues, doesn't give you an error. You told it may not exist by putting the if exists. So I'm going to point those kind of things out. I try to build that in my code all the time. It's really good for teaching like this because Otherwise, things break and you're like, why did that fail? It's like, oh yeah, I left that customer. In fact, if you notice earlier, I showed you SQLite Studio, and these tables are in fact already there from previous demos I was working through here. All right, so let me drop the table if it exists. And what I need to do is do a create table statement. All right, so this is how a create table statement works. And we're going to say create table customer. Now what we really need here, and the reason we have to do this manually, is because we need to define the primary key, the unique identifier. The primary keys are always best done if they can be integers. It makes it more efficient for the database. And integers are good, they're whole numbers, so it makes perfect sense. We're going to say this integer customer key is a primary key, and it cannot be null, because if it's null, there's no way to grab it. Null means it doesn't have any value. It's sort of unknown, which is useless. So primary keys can never be null. And now we have other columns like last name, the birth date, marital status. Now an interesting tidbit about dates in SQLite, actually text can be handled like dates anyway, so it treats them well. Or you can actually put a date column there, and there's a couple of ways to handle it. So date functions will work pretty well with most of these things. So I'm leaving that as text, that's fine. Text is sort of the generic, any kind of varchar, inchar, whatever, it keeps it. SQLite's data types are a subset of what most databases have, and it's pretty flexible. So text is any kind of strings. We've got integers, real numbers we can hold, like decimals, etc. And finally we have something called a date or date time we can put in this case. And if you notice here, we're using the ETL last update. Now let me review what we have. We have the customer key, the last name, the birth date, the marital status, etc. That's the data in our table. The modified date is usually, but not always, present. But it's a good thing to have if you have it. And the reason is, the modified date says, when did this change? Now, if you're getting data from something like a data warehouse, the modified date could actually be when the data warehouse applied that change, which ultimately really came from some back-end system like Salesforce. But better still would be, this is the modified date that was done, say, in Salesforce, or the actual system of record, they call it. And so that will tell you this is when it really changed. That's useful because you may have a modified date. You can look at that and say, well, wait a minute. The modified date I have is from June 6th. This has a modified date of, June 1st. I have more recent data. I'm not going to change the data I have. And that's what you want to kind of use. Now, additionally, what I like to add into any kind of ETL I do is my own extra column, which tells me when did I apply this change. The change could be 6 months ago that I'm finally applying to my data, but I like to know it because it can become very confusing if you don't. Like if you didn't have this extra column, you wouldn't know when I last updated this particular customer, any given customer. But by having this ETL last update, making it a date time, which means it will not only include the date, but it'll also tell me like 2 o'clock in the afternoon, 3 o'clock. Now what I'm doing is I'm assigning it a default value which says current timestamp. What that means is I don't have to actually give it a value. Anytime I insert a new row into this table, it's going to update this column. So it takes care of that work for me, and that's kind of a handy thing to do. So this is really, I think, an ETL best practice. Not everybody may agree with that, but I've been doing it for years, and it's very useful when you go back to a table to say, oh, okay, yeah, I ran the update yesterday. I can see this was updated. Oh, that's interesting. I see on my transaction file, I got in just yesterday, this customer's there, but for some reason, the update date time on ETL last update wasn't applied. It doesn't have that date. And so it's good for troubleshooting, finding problems, knowing when things last ran. So all kinds of good stuff. So I'm going to run this with execute. Execute just says run a statement. I'm not expecting results back. I just want to run something against the database. So I'm going to do Shift Enter. That ran it. No errors. That's good. And now, as I mentioned, pandas is really handy. I can run queries using read_SQL_query, and I'm just going to run queries against the database. What I'm doing here is I'm using what's called the database catalog, SQLite master, which is not exactly SQL standard to do it that way. Info schema is typically what you would use in most databases, but they have, and you can say table. So this is a table which tracks information about tables. So it's called metadata. Now, as I mentioned, I have customer transits already there too. We'll remove and replace that. That's our transaction table. We're going to keep dropping and recreating those anyway. But you can see now we have got our customer table defined, but it's empty. Now what I want to do is correct the problem that we have an empty table, and I'm going to do that by bringing in this data, dim customer CSV. I'm using read CSV, again, another pandas function, which is going to return this to a data frame called custdf. Now I'm telling it I don't want an index column, because otherwise indexes kind of mess it up and you lose the column as a separate column definition. So we're going to say don't do that. We'll use false for that. And then you'll see custdf. You can see what we did. If we had selected this and set the index to be the customer key, for instance, it would shift over here and it becomes more like a row name in R or something. It's like an identifier that's not part of your data. And I think I sounded very Boston-like in that accent there. So, and I am from Boston, so yeah, I got that accent. I also talk quickly, sorry. All right, so these are the columns we've got. That looks good. And we've got customer key. That's our unique identifier. So we're looking good now. We've got 4 rows and we're ready to go in. Now we need to save the data frame to a table, because that's the whole goal. We want to maintain a table. So rather than just having one pre-exist and give it to you, I'm going to make it go through a little work. That way we can kind of truncate and reload, or just delete and reload the data from the table. By the way, when you, in SQL statements, the normal way to efficiently delete all the data in a table is called truncate. It bypasses a lot of the overhead typically of doing a delete. In SQLite, they do not support the truncate statement. So this is why I said stick with me, because I want to teach you the nuances that will really burn you, to be honest, otherwise, because I hit them. I was pulling my hair out. I don't have a lot of hair to begin with, so it's not good to pull it out. So I'm going to save you some of that trouble. So let's look at this. We've got two SQL. We're going to save a data frame to the customer table. That's our connection object. We need that. We're using a method of the data frame, and we're going to say if exist append. I want to call attention to this. We're not saying if exist replace. If we did, we would lose our primary key. Why, you ask? Because if we say replace, SQLite drops the table and recreates it according to what it sees in the data frame. And that means we lose our primary key, which means we won't be able to do any of the maintenance transactions against it. We're also going to say we do not want an index. We've got our primary key, we're good to go. So we got what we need. So let's persist this and let's take a look. So here we are now. Now mind you, this is not looking at the data frame that we did up here. We're looking now at the actual table by querying against it. We can see we've got all our data, and this is great. Notice ETL last update. We didn't have that row, and this is kind of a cool feature of SQLite actually, because we were able to persist with append, and not only did we keep our index and structure, but we have this column here that tells us when did we do this action, when was this. This would tell us if we were to look back, this row was inserted on this date, or at least last changed on this date. And then we have all this stuff. So pretty riveting. All right, so we got what we want. I think we got everything here. Let's move forward a little bit. Now, if you are like me, I forget what column names are called. I forget what the types are. To get a list of the data frame column names, and we're going to keep the data frame around. It's kind of handy. We're going to reuse it. We can just do columns, the data frame name.columns. That's a pandas function, and it's a handy one. We can also get something a little more informative, like not only the names, but the types, and nicely listed, suitable for framing. So this is two ways. I definitely prefer the second because it tells us types as well. Generally, when you're dealing with data frames, if it says object, it means it's a string, so you can pretty much infer that. All right, now we're going to import pandas just to make sure. We did have that earlier, but just so you realize, nothing up my sleeve. Pandas is being imported with a PD prefix. We've been using it, so it would have to have been. Another way we can get information is to actually query the metadata within the database, and we can use a pragma statement as well. We saw how to use the SQLite master table, but we can use a pragma, and this is a little nice because we don't have to do anything special. Pragma, table info, and the name of the table, and we get the column names in proper order, the way they're created, whether it's null or not, and the default value, and only the last column has a default value. Another nuance. SQLite does not have a Boolean data type. What's a Boolean data type, you ask? Data type, you ask. It means it's a data type that can hold true or false. So a lot of databases tend to have that now. SQLite didn't. You can just use a 0 or 1, and that's what SQLite does. So when you see something like not null or null, the 1 means this does not allow nulls. And the PK 1 means this is the primary key. So the other ones all say 0. So again, there's no true false, just zeros and ones in SQLite. All right, so we got a nice table. We're good to go. All right, so now I want to show you the generic insert statement, something that all the documentation online is going to show you, and it's virtually useless, but it is good to demonstrate so you understand the mechanics of what we're doing. So the insert statement looks like this. Insert into the table. You don't always have to. If you match your values, the number of values and types perfectly with the table, you don't have to list the columns. I recommend you always list the columns because they can change. Somebody could go in. Now, granted, this is your own table. It's not as likely. But in general, in databases, people could add columns. They could change things. And by explicitly listing the columns you intend to insert, you not only document it and make it clear to somebody what you're doing, but you avoid a problem if your source data were to add something new. Imagine if we didn't do this, for instance, and somebody added, so, the person's gender or something into this. Well, then a value statement would say, well, you're missing one of the columns, and it would fail. But even if this table had, as long as that column is optional, you don't have to, it supports nulls, we could run this even if you added 10 to 20 more new columns to customer. They just get set to null, and the statement still works. So that's my soapbox on this. But here's what we're going to be doing. We're inserting hard-coded values. And it works, and we can just look here, and sure enough, we can see it in this last row. That's great. Again, I know this isn't very practical. I will get practical in a moment, I promise you. But I want to show you again another one. Here's the update statement. Now this update statement looks pretty good. I'm pretty convinced this is okay for an update statement, but I'm wrong. Let me run this, and then we'll see what happens. The update statement like this is fine. We're going to say update customer. Now the key thing is we're the customer. This is the unique identifier. We're going to do this particular customer. 11001. So we're going to change this one. Hung, I don't know if that's the right way to say that, but assuming it is going to change to have a last name of Jones. And the marital status will go from single to married. Now, one of the things about the update statement is I don't have to update any particular columns, which is useful. I can just say, well, like for instance, birthday's not going to change, so I would never probably update the birthday. So I can run this and just show you what happens, and you can see Jones is now the name, and they changed to being married. Awesome. So these are pretty basic statements. The delete statement is probably the simplest statement in the DML set of verbs, and we've got delete from customer. Now the only thing to be careful of is that when you say delete from table, if you don't qualify it, it will delete every row in the table. I'll say that again because you will burn yourself if you do this. How bad it is for you depends. You don't want to do this in a production table. It's a good way to get fired. But if you say delete from table and you delete every row in the table, that's what it will do. It needs to know, again, what key are you looking for. So we're going to say the customer key is 9999901. We're going to delete that row. That would be the last one here, Zach. Okay? And then we'll do a query to make sure it worked. And lo and behold, you can see Zach is now gone on the new list. Great. So we've covered the basic statements. Now the problem is, it's a lot of work. If you had 1,000 changes, I don't think you want to go in and start hand coding each individual change. So what's a different way to do this? Well, you can read in a transaction file, or if we already had a table that was going to support this, we could use that. So what we're going to do is we're going to pull in a CSV file that typically the imagined scenario is here. Maybe a vendor sent it to us, or we extracted it from a database table and downloaded it so we can apply changes. Now we could just as easily go directly against the database and pull it in, but I'm just going to keep this simple. If you're wondering about how to read against databases and use it within SQLite, I'll post yet another link, but there's a video I did all on that, and it's riveting. But we're going to use PD read CSV. We're not going to do the index column, as you noticed, and let's just see what the transactions look like. Okay, so here are customer keys, and we can see we've got some transactions, we've got last name, birth date, etc. So let's take a look. What I did to specifically make this easier to follow is I added a column to the transaction file called action indicator, and that's to tell us whether we want to add, change, or delete. When we want to add, it's going to have an A, so you can see these two rows are going to add. We want to change, it's going to be U for update, right? And then we're going to delete, it's D. So we can have one delete, we have two adds, and we have two updates. That's what's going on here. Now notice the modify date is 2020-01-01, 02, And this can happen. You can have different modified dates. Probably on the source system, this is when those particular things changed. Now you want to make sure that you don't take something with a modified date that's earlier than your date, your latest modified date, and update it or delete it because, or mostly update or insert, because you'd be in trouble. And really that's only applicable, I guess I think about it, for updates, right? But you would be taking older data and replacing newer data, so that wouldn't make sense. Okay. So now what I want to do is take that transdf data frame, and I'm going to persist it using the toSQL to a table called custtrans, and I'm going to use a connection. I'm going to say if it exists, replace it. Now why am I not appending it the way I did with the customer table? The reason is I don't need a primary key. This is just source data coming in. I'm not going to be doing inserts and updates to this table. I'm just using it as a source to do those updates. So I'm actually letting it delete and replace. I'm not even going to create the table definition. I'm going to let it work, just generate that off the data frame. No index, and voila, we have our table. Again, this is the data frame, not the table, but now we've loaded it and we have all the data we need in a SQLite table. And now we can start having fun, because this is where the real work begins. So what I want to do here is I want to reset my data. We've mucked around, we've added, changed, and did some stuff. So to reset everything, I'm going to run these 3 statements. And this won't be the last time I'll do it. I'm going to run one statement that is going to do what I told you not to do generally, which is delete from customer and no filter. Then I'm going to create my table all over again using the append. So I have an empty table, right? I deleted everything. Now I append to it. And then I'll confirm everything looks good. So I'm just going to run this cell. And we have back our original 4 rows of customer data. And that's so we can now see a different way we could approach transactions. Transactions are here. And we're finally set up to go at it with using the table to drive our transactions. So let's start with our insert. We're going to say insert into customer. Again, being Pythonic, mind you, which is explicit is better than implicit. We're identifying the columns. And we're going to say select these columns from custtrans, right? And notice we're not specifying the ETL update column because that's defaulting. We don't need to. And we're just going to bring this data out. But we're going to do it with the action indicator is A. So we only want to do that. Now, it's optional to use a doc string, the 3 tick marks, 3 quotes, Python to do this. If you're doing a single line, you can use single quotes or single quotes as opposed to a doc string. But I'm going to do it this way, which is kind of nice because I have to include these quotes around my A, so it formats it correctly. Now, mind you, this is where having, again, you're doing insert statements, are getting a little hairier. You can go into SQLite here, and you have a query editor, and you can test your code here, run it, and make sure it works before you try it within your Python program, because obviously it can get a little confusing and tough to debug when it's just running in a string. So let me run this. And what I did is I should have added 2 new rows, and I made the keys large so you can see. So there they are, Jane and Murphy, all added. Cool. So it worked. So now let's talk about the update statement. Now, as I mentioned, you generally want to use an input table to drive your transactions. You could have 1,000, you could have 1,000,000, it doesn't matter. The update statement in databases I've typically used like Oracle, SQL Server, and Postgres support the idea that you can say, I want to update my customer table, and here's what I'm going to update and join it to my customer transactions. And then I can put an alias on the customer transactions like CT, we'll say, and then I can just say, okay, update name to ct.name and address to ct.address, etc. And it's usually very efficient and very easy to follow. Unfortunately, the SQLite update statement doesn't support this. Instead, you're saying update orders, and you can't even join directly, so you're going to say instead update item name. And by the way, this is not a workable code. You can't run this at home. Sorry. I started going down this road and I abandoned it because it's just too much work, and I don't think it's a good way to go. But I'm demonstrating it here just as an example. The link, if you want to follow it, is up here. But what you're doing is you're running a subquery here, where you're doing a join to the outer orders table to your internal table, this table here. So you're selecting from product masked and joining here. And when you do that, it's going to find the matching product name and return it. So you're actually running a full query for each individual for that column, and you're going to have to keep returning the row for each instance. And you're going to have to do it again for this column. Now imagine you had 300 columns in a table. This is going to be unwieldy to maintain as code. It's probably going to be unwieldy to execute because this is an awful lot of work for this SQL statement to run through. So it's really a poorly done SQL statement. I'm sorry guys at SQLite, I love your product, but you guys should really fix this. This is just bad. I really can't say anything. I wish I could doctor that up and say otherwise. However, I'm going to show you guys how to get around that problem. The first thing is we're not going to use it. Let's take a look at our one update row. Oh, we have two update rows. Okay. So we got two rows we have to update. We're going to pick a different way. There is a pretty useful statement that works better than what we saw, which is called insert or replace. So we saw insert, but now I'm going to use insert with replace. Now here's the trick. I could say replace by itself, but it implies the insert as well. So I want to be explicit. I'm going to say insert or replace, but I'm going to only filter it on the update. I've already inserted my rows. I don't want to insert more. I just want to use this technique to update my rows. So I'm going to use replace. So again, back up, rewind. Replace is not really an update. Replace is very much like what I said about data frames. It deletes the table and replaces it. So what's going to happen here? It's going to delete the row and then reinsert it. So we're going to be running a query here of our table or data, right, where the action indicator is you. We're going to get these two rows. Now what's going to happen is if it has a conflict on the customer key, which is the primary key, it automatically looks for the primary key and will say, I'm going to match on that. And if it doesn't exist, it will do an insert. But in this case, it's an update, so it should exist, and it will. And we're going to just replace it. However, there's a problem in one sense. Something can go wrong. It will work. We'll see it. Let me show you. We said update, and on the particular instances, 1100 and 111. So these two rows, we now have Yang and Jones. You can see them here, and the yearly incomes have changed as well. It's a different income, etc. We can see also that the ETL last update looks like it changed that as well. So I think we're good to go. Okay. The problem I have with this, and this is really warnings that you see in the SQLite documentation about the insert or replace, is suppose we left out this income and it was 0. Well, we don't have a choice or control. We might have had a good income, but now it's going to delete it and replace it with zeros. Well, that's not good. We might have nulls. We might end up with marital status, and we went from knowing what it was, but now we get a null. And as long as the null's allowed, we're going to replace good values with bad. But more importantly, suppose we had something where we had a constraint that said they must provide yearly income, and there's a null being passed in. Well, what's going to happen with the replace is it's going to delete, and then it's going to replace the entire row, which means it could hit some sort of constraint which will cause it to fail. So you have a good row on the table, and you end up losing the row altogether, because if it tries to replace it, it'll delete. When it tries to insert, it could fail. So you end up with nothing more than a delete. So that's the problem with it. You have to be very careful when you're using it, because you can get burned on something like that. And they have warnings in the documentation saying use something called an upsert over this, and which is the reason they created the upsert, as far as I can tell. But in our case, it works. And it's really the only viable workaround to get a decent kind of working update. So it's a pseudo update. It's not really an update. But again, that update statement, yeah, I'm not going to beat it up anymore. All right, finally, we want to talk about deletes. So here's our delete row. We're pulling this out of the transactions, right? All we have to do is we're going to say delete from customer, where customer key in. Now, mind you, this is pretty much the same as the update, but delete's a very simple function, right? A statement. Let's delete where something is true, and we're going to be deleting on the unique key. Mind you, a delete statement could say delete wherever the gender is M or whatever. It could be any kind of thing. So you do have to be careful. You want to not delete too broadly. We're going to be doing it specific to the customer key. Now what we're going to say is we're going to delete wherever the customer key from cost trans is D. So what we're really doing here is we're running this query, and it's returning a list of keys to the delete statement, and that in clause is just going to say delete where any one of these items that came back is where it matches that. It works. It's not a great way to do it either. Again, typically with a delete statement, just like update, you would do a join and it'd be more performant. But since this is the only way you can do it, and it's not bad, it just won't scale very well. I have a feeling that if you had like 1 million or 2 million rows this way, you might have issues because it's going to try to return all those keys and do an end statement. Not the best way to do it, but we can do it, and we did. So we wanted to delete 111.11002, and you can see it would be right after 11001, and it's gone. So that was great. Hope you liked it. This was to show you how to do the sort of traditional approach to doing statements and maintaining data in SQL. Now, before we get into the next one, I would typically purge and delete. I'll recreate my table here. Great. But I'm going to end this video right here because I don't want to go into forever. But this video is really meant to be the first part of a longer video, which is going to be part 2, which is going to show you a better way to do this, which is called an upsert. Now, the upsert is not trivial to understand. It's actually kind of hairy, and it has some variations. But it does give you some flexibility, some simplicity in some ways. It has better functionality than the things we've seen already, I think. The only thing the update will do, the update and insert, it's better than the insert replace, but it does not support the delete. So if you're like me and you've used something like the merge statement in SQL Server, which is really powerful and can do just about anything, this is not that. But it's pretty good, and it gets you through a more robust maintenance command. We talked about what is data maintenance, and we saw it's not going to be current after a while. Things change. And that's why we need to maintain the data. We need to keep it up to date. Not going to be very useful if we keep showing somebody the same pie chart for 10 years. It's going to be like, Brian, I've been seeing the same bar chart, and it's been 3 years now, and it hasn't changed once at all. Oh yeah, need to change the data. So that's why you don't want to do that, right? It might not go well. Now, the traditional data maintenance language statements are the ones I showed you, which are insert, update, and delete. And we saw this little oddity that's specific to SQLite called the replace statement. So useful, but you got to be careful because it deletes and then inserts. And I talked about the tools of the trade. SQLite Studio is a really good thing to get. If you're going to get into this level of working with SQLite, you definitely want to have something like SQLite Studio, or if you prefer something like things called DB Browser, that's fine too. And we saw a riveting demo. Hope you liked it. Very involved. I realize you can get the code out on the internet there on GitHub. I'll post it as I send in the links. And that's about it. So hope you like this. I'm going to be working right on the tails of this video to continue on to the upsert statement, which I really ask you to watch that because that's where I really started. I wanted to go to the upsert, but then I realized I need to give you the background. It's not enough to go to the upsert. An upsert may not fit all your needs. For instance, you do have to be up to almost the most latest version of SQLite for it to work, and you may not be able to do that. And there's some nuances to it. So until next time, please like, share, subscribe, tell all your friends about my videos. I hope they're useful. Look me up on LinkedIn. I like to connect with people, post in it, send me a note saying you watch my videos. It's always good to know people are watching this stuff. And yeah, I'm pulling for you. We're all in this together. Take care.